Hello, everyone. Yeah? Sleepy? Last talk of the day, is it, right? OK, it's fine. So then we're going to do something complex. So you can actually go to sleep with some substance. No, I'm kidding. How many of you have tried Kotlin Native? All of you? Well, then, bye. No, I'm kidding. So hi, I'm Eugenio. I'm a developer advocate for Kotlin Multiplatform and mobile at JetBrains. I generally don't introduce myself, that's why I forget. And this is sort of the story of my journey in trying to discover Kotlin Native. Normally, I talk about this in a multi-platform setting, in the sense that I talk about Kotlin Native as in, you share code across platforms. But Kotlin allows you to pretty much have the granularity that you like, in the sense that you can share stuff, but you can also go full in even a single platform. And sometimes even like the thought of where does Kotlin end and where does the platform start can be tricky. And so what I wanted to do was try to experiment and push as much as possible the limits, let's say, of what is possible to do in Kotlin Native only in Kotlin. Now, specifically, when I say this, I mean macOS and iOS. Because at the time, what I wanted to do was create an app, and all the samples online are for iOS, not for macOS, for example. There's one little sample, but it's not great. And also, when you open it, I'll show you, more or less, oh, actually, this is already the beautified version, but more or less, this is what you get. It's not extremely pretty. But yeah. Also, the output of that is a KX file, which is like a binary file you can execute. And that's not an app. Like on macOS, apps are these things with an icon. You launch them, they do stuff. And there was nothing like this. So I was like, what am I missing? What is the secret here? On top of that, Xcode. Have you ever used Xcode? So sorry. So sorry. Yeah, so I wanted to see if I could try and avoid that. And just to make things more complicated, AKA fun, I thought, well, you know what? Do you have a Nintendo Switch? Yeah, a few? OK, perfect. Yes, yes. And you all know also that presentation remote that you can sort of point in the air and the cursor moves, right? Yeah. So I said, well, I have a Nintendo Switch. I don't have that. And I have really bad ideas. So why not try to make it with the Nintendo Switch controllers? In Kotlin Native, of course. And now I'm going to show you the project that came out of it. It's going to be very flexible. So if at any point you want to ask me anything or you want more clarification or whatever, just stop me, and we can figure it out. So where to start? First of all, there is a website that I hope now I have internet. Let's see. Oh, yes, OK. So it all starts not in Kotlin, but on this amazing website. This, can you see? Is it big enough? Well, this website is amazing, and they pretty much reverse engineered a lot of things about Nintendo Switch. Well, I mean, of course, like hardware and stuff, protocols, etc. The really interesting part, the one that we are interested in, is mostly Bluetooth stuff. So if you go in here, and it looks scary, but once you get it, it's not that much. You have all these commands that you can issue, get back stuff, etc. Of course, all the samples are like C or whatever. And you work with bits and bytes quite a lot. Now, you don't have to know how this works, but more or less, you have this HID manager, which can enumerate all the connected devices. By the way, fun fact, Bluetooth and USB have pretty much the same protocol. So you can essentially make one and the other work the same way, which is really cool. And so you do this, and what happens is that you enumerate the devices, you open a specific device, and then you can start sending reports, they're called. Well, they're like requests for more data, for something, and then you get things back. And you communicate like this, blah, 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 blah. OK. So started here, and I wanted to do it on Kotlin native. Now, the API for like macOS for this stuff are not even in the foundation framework. I don't know if you know the difference. So there's foundation, they call it, which is this higher level framework where you have all the basic runtime stuff. But then that's built on top of core foundation, which is the even lower level one that essentially it's like really low level, to the point where even the reference counting is different in certain ways. Now, Kotlin interopts with the Objective-C runtime, the ARC, nicely for the foundation stuff, not for the core foundation. So that was something that I had to figure out. I'll show you how it works, more or less. So they are a lot more lucky than we are in the sense that on iOS you can change between the types. It's called toll-free bridge, if I'm not mistaken. And I'll show you how it works. Yeah, so essentially you can convert between one and the other normally without doing anything special. But if you are not lucky, so let's create a new scratch in Kotlin. Can I put it here? Yes. Does it work? Can you see? OK. So normally, Kotlin types are not a problem. You can say something like, I wonder if I'm not having the module stuff set up here. Wait a sec. Come here. 1 second. Let me just, module. That's why. Right? If I do this. Yeah. Yeah, no? OK. No, it doesn't pick up the, I'll just create a normal file, because otherwise it won't work. Where are we? OK, new. OK, now, as we were saying, yes. You can do things like, you have a val, foo, whatever. This is a normal Kotlin string. Ooh, why does he complain even? Oh, right. I should probably mirror the screen, but it's still a mess. So, normal Kotlin string, everything's fine, sure. If you want to make it an NS string, which is from the foundation framework, you can just cast it. So you say as NS string. And yeah, it does complain, but it is actually fine. For this very reason, I did a few extensions like this, if that's, or is it as? Maybe. Yeah, I guess it is. Yeah. And then this way, I remove the cast, whatever. And this is fine. Every time you convert, it internally changes like the reference count so that you sort of borrow the object, and when the collection happens in Kotlin, the other side is not concerned, so that's fine. But if you want a CF string, as in core foundation string, then that's different. And if you look at all the core foundation methods, they're very C-like in the sense that instead of taking an object, because there's no objects, you need to create it. And to create it, you need to do something like, well, let's have a function just for the sake of, right. So you do something like cf create, if I'm not mistaken, or cf string, I guess. Yeah, and then you have all these things that essentially take bytes, and you need to allocate stuff in order to just do something simple, like creating a string, which is intense. And not just that. Once you finally do have one of these objects, well, if you create it, you own it. So you need to remember to release it. And if you get it as part of a method or something, you need to retain it. So let's say show interest that augments the count, and then you need to release it after. So you need to do something like cf retain, and then you pass the whatever variable, and cf release on the other side. And the point is that this is sort of scope-based. So as soon as you get it from whatever, you need to immediately say, yes, I want to retain this. And then at that point, it's your responsibility to unlock it, let's say. And you can do this multiple times as long as the count of how many times you retain and release is even. So that's fine. OK. To make it simple, I created a few extensions that I can show you. So let's see. I'll actually start by let's try to actually do this now. Display. I will start mirroring, because why not? Arrangement and mirror. Boom. OK, it's not too bad. I wanted to see if, no, brightness, whatever, but can we scale it a bit like, OK, yeah, sure, that works. All right, oof, it's a bit, can you see? Oh, I love it. It's ginormous, I love it. OK, let's even do this. All right, yeah, so, all the boilerplatey conversion from one to the other, blah, 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 blah. This, I'll probably open source this. You could get this technically as supported by Kotlin. They haven't listened to me yet, so it's not there yet, but it might come. The problem is that if you need to do any low-level thing, you'll need to do this, and it's whatever. And so, OK, fine, that's as far as this part goes, sure. And why am I saying this? Because if you want to, again, talk to the Bluetooth stack, essentially, you need to use APIs from Core Foundation. So you need to deal with this, unfortunately, and that's error. All right. The other thing, so more or less, the whole lesson was, it's not even that you don't understand or don't know Kotlin native, is that you just don't know the platform. So in the end, what I had to do, despite, the wish is always, oh, by using Kotlin native, you're just going to have this silver bullet. You don't have to learn anything about iOS, about macOS, whatever. That's not the case. If anything, you probably should learn about it even more to be able to do things properly. So that's what I had to do. It was actually pretty interesting. And again, so you start to understand things like, what is an app? It's a folder with one difference. It has a specific sort of manifest file. It's called info.plist. So I'll show you, for example. So yeah, you see it here. It's like an XML thing. There's not much, just a few things. All of this, of course, is documented. You can find it on the Apple documentation and stuff like that. Or you can also do a trick. You can steal it from other apps and modify it, whatever. Yeah, so that's it. And in order to make this work, the only important part is that it's side-by-side where the execution binary is. So in this case, if you look at the build folder, put it here. And just because this is there, then it works. Then it's a real app, and it just runs. So that's the first part. The second part is, if you create an Xcode project, you just have this main entry point where all the application is set up for you, and you just write your app delegate, blah, 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 other things. I don't want to use it here. So how do I set up an app? What does that magic do behind the scenes? That's what I wanted to understand. So every Objective-C app is a C app in the end. So it all starts with the main method, right? And you normally have an annotation, if I'm not mistaken, called NS application main. In this case, we are sort of doing it by hand. So how? We do create an app delegate, which is just a class that extends this protocol. I don't even, if you want to see the, yeah, you probably don't, but there's a lot of methods. It's the equivalent of an activity, but delegated, so it just calls the methods for you. You need to extend NS object because you're in that realm. Still on the extends any in any case, but still. And then, so if you really, because this is low level essentially, right? So you need to decide where you want to paint, and so you need this display rect to say actually, on which surface your thing is going to draw. And then just to make it clean, I passed a callback that from the outside, you give me a way to stop the application, and then from inside the UI, I can actually call that and stop the application, for example. OK. Yeah, this is just, just to make it easier. And then mostly what you need to do is to create a window if you want to draw. And so you can just essentially read what's here, but oh, this is interesting. So this is a struct, which means it's not really an object you pass by reference. You pass it by value. And what that means is that it literally is copied everywhere, except Kotlin doesn't have support for that, really. So this super neat trick that they use is that you have this use content function. And what they do is that they copy it in memory temporarily and actually do create an object. And then from inside of that, you can access it. And as soon as you're out, it's deallocated. So it's a nice way to do it. If you need to create it, I'll show you later. But you literally allocate it. You do something similar to initialize it. And then you can just launch it wherever you need. And this is the real trick. The real trick is just here knowing the platform and passing the right styles. It's as easy as that. It's like saying on Android when you pass the wrong style and you get the gingerbread theme. It's exactly the same. And once you, by the way, there's a lot of flags that are really interesting. You can make things without a shadow, with a weird shape. You can make them so that you can't, resize them or you can't do whatever. It's a big framework, of course. Once you have that, blah, 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 you create a window. This is still part of the sample original. You can give it colors, etc. Blah, blah, blah. OK. And then you actually compose the UI, which is the interesting part, right? So here, again, if you wanted to use Xcode, you would have storyboards and all of that. And you can, of course, load storyboards programmatically if you want to. I just didn't really want to use storyboards at all. And you can do everything. Actually, behind the scenes, even storyboards, they're just programmatically loaded. It's like the XML for Android, if you know that. But that means you can also programmatically create any element of the UI. And this is what I'm doing here. And so you can even make it look super Kotlin-y and just keep saying button, blah, blah, blah. So for example, this is a function I create to already pre-pass some parameters. And then I use it here. And it's super clean, right? The way it works. Interesting thing. So you start seeing all these little bits of platform-specific things. For example, if you want to give it a callback, right? So in this function I created, it takes a lambda. And you think, sure, no problem. I'll just set the callback, right? But you don't just set the callback in Kotlin native, or I guess on the foundation framework. You have to put this sort of annotation so that then the runtime knows that the dispatch is on that method, and it's sort of magically sent there. It's kind of weird. So I abstracted it, because why not? I created this callback class. And this is what I was talking about. This is a Objective-C action, which is a special thing that happens. And just with this, it would work. With one little caveat, as soon as you're, like technically nothing is really keeping a reference to this. So as soon as you are done setting it, and then you do something else, you come back, you try to invoke it, it might be deallocated by then, which is a problem. So what you do is you need to associate it with the life cycle of that object. And this is literally talking to the Objective-C runtime, okay? We are just saying, when you do your reference counting, whenever you're essentially deallocating this, then also deallocate that. Otherwise, don't. And yeah, so because it's a weak reference also. And with this, it just works. And it works, it's not a hack, it's actually how the platform works. So, it's nice. Little thing that I really love, normally when you do this selector, because that's the non-type safe part that I don't like, this action, they want you to pass here the name sort of like this, right? What could possibly go wrong? Like, I don't know, maybe you just do something weird, and then it doesn't work. And so we can use the amazing power of Kotlin and just use like a property reference and then just take the name. It's always going to be updated. Fuck it. OK. So this is one trick, for example, out of the many things you can come up with. And you can really start making it look Kotlin, essentially. So blah, 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 we create the window. On the window, which is like a root view, we added the subviews, etc., blah, blah, blah. That's it. And this is the main entry point, right? You have these like delegates, essentially, functions that whenever things in the lifecycle happen, then you get called and you do things. So here, again, like this was just hacking around. Like a few things I did in detail because I wanted to show stuff, but this is super hacky. Here, for example, we call this main method, which is where I put all the logic about the Joy-Con stuff. So I'll show you. First of all, have you seen the concurrency talk from Kevin? If not, I'll wait. You can watch it now. OK. But essentially, I also wanted to demonstrate how it would look like if you wanted to do like sort of a Redux-style pattern where you have immutable state, you sort of emit events, and then you reduce those events and have one place where everything is computer as far as state goes. But then everything else is in different threads and does whatever it wants, and it should still work. And let's see if it does. So actually, let's start from this very method before anything else. If you want to start a thread, so normally, when you talk about asynchronous stuff, you say something like, I want to do an operation. I want it to be in the background, and then I want something back. That's it. In this case, it's very different. You want something that runs continuously, like a loop in a loop, let's say. So you really need like a thread, or at least a place where that lives. And in this case, I did exactly that. I did like a thing so that it could live somewhere. And the way you do is that you create an NS thread, and you pass it a lambda. And the trick is freezing the lambda. Otherwise, it will not work. And you know how it is in Kotlin native. If you want to let something go in other threads, you need to freeze it. So if it's frozen, you can let it go. Thank you. And then this is the interesting part. So again, if you know Android, you know like handler threads. So event queue happening, and that's how events are processed. This is the same here. So we get the current loop because every NS thread has a loop associated. This is actually the low level. Every time you see CF, it means core foundation. So you get the low level loop. We retain it. And then this is just something I created. I was missing it from Java, so I created a closable interface because you have to. And and this way, I essentially made it so that in the init of your whatever thread code, you already have access to the cleanup method to the thing. And then you have a dispose method where whatever you created in the init can get disposed as well. And this is how it works. Well, you init it, and then you make the loop run. And so this is blocking, essentially. This will wait until there's new messages on the thread. When there are messages, it will just continuously update them. The only way to stop it is to stop the loop, or I guess kill the process. But and you stop the loop from here. So, I already provided both the initializing and closing behind the scenes. You don't even see it, essentially. And then we dispose it at the end, blah, blah, blah. We already set a name and start it. That's it. So you can imagine that from here, anything inside will be on a different thread. So let's go back to that. Did I go too far? I did. OK. So we start this reducer thread. Cool. Then the point is we sort of want to have a circular dependency, because we want data to flow in one direction only. OK? So we want whatever is happening, like side effects, to emit events. We want the reducer to see the events, reduce them in a new state, and then send back a new state. And that's the cycle. Okay? So in order to do that, since we want everything to be immutable, we have to do a trick, and it is using this atomic reference, which is sort of a placeholder where we promise there will be something on the other side in the time that you're done. For now, there's nothing, but that doesn't matter. And we also keep one just to have a place for the state to live, like the latest state, so that we can get it back and set it. Once, no, not now. Once we have that, so again, there's this, in order to use the platform, I started just digging in documentation, like how do you send something on a loop in a different thread? And there's a bunch of things. The easiest way, I guess, is to create a port, which is nothing more than, the way it works is that you can stop a loop by either having a timer, which is time-based, interrupt, or a source, which is a source of events that can stop the loop, make it process stuff. Otherwise, the loop would just wait forever. If you don't have any sources, actually, it closes down. So you create a port, and this is, again, like a helper, essentially, where you see, again, all the retain stuff. It's a bit annoying, but it's not too bad. Also, the runtime tells you if you forget, because by the time you close the process, it will tell you that there were leaks happening because you didn't properly release stuff, for example. And so, for example, this is one of those things, or is it? No, this is not, whatever. We create this port. You don't need to know all the details, but we need to often do this thing with passing callbacks. I don't know if you've seen this before, but if you need to go through a C function, you can pass a live callback, as in a lambda that is actually stateful, that has references to the outside. You can't. It has to be completely pure, completely static. And since they know that this is the case, they always make it so that the first parameter, or a parameter, is the mutable part that you need to actually execute the lambda. And so in this case, the mutable part is, more than one, I guess. And you do this sort of wrapping, unwrapping. So normally, a Kotlin object lives in your scope. But then as soon as you sort of leave the scope, it's gone. In this case, we are crossing boundaries, going to C, etc. The runtime would have no idea when to release and keep stuff. So we tell it explicitly, please create a stable reference to this. Once you have that, then of course it's your responsibility to release it as usual, but you can pass it as a C pointer. And then suddenly, you get it, see the info parameter, you get it back on the other side, And then on the other side, you can put it back as a stable reference, get it, and then use it. And this is how you do the whole thing. It looks weird, but it's actually really clean in the sense that you can do the same on the JVM or anywhere else where your logic is completely stateless, completely blocked. And then you just have this, you inject these arguments on top of it. Blah, blah, blah. Again, you don't need to know all the details, but the nice part is that by having this closable abstraction, you can just put all the cleanup in one place. And then you have these objects that you already know that are going to be clean in the end. You can even chain them, and they just get closed all together, so that's fine. Blah, 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 blah. So sorry, let's go. Yes. So I promised you to show you a struct of how that would work, and this is it. So this is a struct. Actually, if you look at the type, it will probably look, well, it even tells you it's a struct, okay. And if you try to create it or something like that, it would complain very much. Yeah, it would just want a row pointer to it, which it's like the opposite. You want the pointer in the end, but you don't have it yet. So you do this alloc, and in order to allocate any memory, and this is the point. So as long as you do Kotlin, pure Kotlin, without calling any C or platform-specific functions, you don't need to care about memory, which is great. If you've seen around, we have not really touched memory except for, again, platform-specific things. There are times, though, where you do need to interop, and you need to provide a scope, generally, where the memory will live, right? What is the life cycle of this thing? How long do you need it for? And in this case, we need that for creating the struct, and it is this memscoped part. With this, then you can finally, do the thing. There's other ways, but this is the, let's say, safest. And one thing that it took me a bit to understand was, sure, but I'm passing data to something else. What if, I don't know, they live longer than this scope? What happens then? And that's generally not a problem, because, again, since the C world works like this, they all know that the moment they get something, that's something, and it's a pointer, it could go away. So they just, keep it for themselves. They keep a copy, a reference, whatever. And so by the time this function returns, you can be sure that the memory is not going to be needed anymore. Either they used it, and that's it, or they kept a copy, they kept whatever. So it's fine. And if you start thinking like this, it makes it a lot simpler. And then I started realizing that the documentation also tells you, in the specific cases where that's not true, you will know very well, and so it's fine. Blah, 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 blah. And see, yeah, we are creating this source, which is, they're very verbose, these methods, extremely. And you add them, et cetera, et cetera. OK. So once we have this port, sorry, I forgot the important part. The interface for the port is super simple. You just send stuff to it. That's it. And I have abstracted all the serialization, deserialization stuff. So you can just send anything, and that's it. And we even pre-freeze it, because then we are super sure that it can be shared. And let's go back again. Yes. So now we're coming back to the main thing, right? We create a port for the events. So this is going to be used by the side effects parts to tell the reducer that something happened. We essentially say exactly, yeah, and when we create the port, that's also the trick, you already have to provide the callback. So it's like, when this port will receive a message, what will it do with it? And so in this case, we receive an event. We want to reduce the state. And so we say, oh, actually, that's not needed anymore, I think. Yeah, no, it was written. Damn it. Never mind. Yeah, so we said, OK, this is the event. We reduce it. This was the old value, which we dereference from the atomic stuff. And atomics have the peculiarity that you can freeze them, although they're still technically mutable, which is sort of a fringe thing. But so this is the only reason why this is fine, because at some point you do need a bit of mutability, but it is a very controlled scenario. And as long as you don't introduce cyclic dependencies, everything is fine. So you're going to be fine. All right. And what happens is that, again, like we just reduce, create a new state, set the state in the reference so that we have it for later. And this is the promise we had before. If there is something set up here to dispatch back, then we send the new state to whoever is listening. And once we have that, that's it. We use an also because this returns a closable, so we want that to be the last thing. And that's it. And then once we are there, just because, we start another thread, because we want to compute the state on one thread, but then we want to handle all the device-specific stuff on a different thread. And I mean, just because I abstracted it, high level, how you want this to work is, because we are working with immutable. Actually, I'll show you the state first. I think that works best. So the state is super simple. You just have an ID for devices that we generate. It's like a monotonically increasing integer, right? So we just want to know what was the last device that was ever found and what devices we decided to keep because they are actually useful for whatever. That's it. The type of events that you can do are a device was found, and this is the ID, and this is the name. A device was removed with this ID, or the fun one, a number of buttons, state has changed. And so you're going to get this, thing that you'll see later, and you can know exactly what was pressed, etc. Okay. These are all the events possible, and this is all the state possible. So of course, we want to then know how to handle that, and I'll start by showing you that, which I think is the easiest. Where are you? Board, blah, blah, blah. Ah, yeah, this is the reducer. Super easy. So you're doing your reducing, blah, 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 and then you say, when the event is a device found, then you say, well, if the name is one of these two, because that's how it works, like all the Joy-Cons have this name via Bluetooth, so you can't go wrong, essentially, then fine. Then we return a new device, otherwise whatever. And then we create a copy of the old state, and we say this is the latest ID, blah, 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 and we add the device to the set. That's it. If the device was removed, of course, we want to say, OK, so we essentially remove it if it was there, etc., trying to avoid creating an extra copy, etc., blah, blah. And for the buttons, I didn't do anything now. We can do a print here, but ideally from here, then you can, I don't know, bind it to an actual button click or start moving the mouse or whatever you want. Update the UI, for example. So this is all the real business logic, I guess, of the app. Once you have this, then you have this sort of driver on the side to drive the side effects related to the devices. And that's what was up here. So, OK, devices manager. And you'll see one other thing here, this thread local. So this is the place dedicated to actually, making all the side effects possible. So this is the thing that's keeping track of all the dirty stuff, while your pure logic lives up there, in the cloud. This does all the work. And so what happens is we made it, abstract just to make it a tiny bit more clean. But apart from that, it's quite easy. So you want to know what happens when there's a new state. You want to know how to open a device, how to retain and release a device, essentially. And then, again, you keep a var for yourself. You keep a list of devices and open devices. And again, because of the fact that this is thread local, you can have these vars, and you won't blow up. Blah, blah, blah. Inside of this, we create another port, which is the opposite port, the one that actually receives the state. And we can do already the closing up, etc. And it starts to become very clean once you have this symmetrical pattern up and down. Like, for example, in the open devices, it's literally just device ID related to a closable. So you don't even care what or how, because this is not going to handle the devices as the business logic. This literally keeps a reference to them so that the business logic can use them if it wants to. Otherwise, they're gone, and we don't care. And yeah, so just pretty much boilerplate, essentially. So we increment the device ID whenever there's a new device, blah, 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 blah. We can add it, etc., remove it, blah, blah, blah. So this is really not very interesting. It is more interesting when we use it. Are you here? So we subclass it by providing the actual methods like retain, release, blah, blah, blah. Open device, I'll show you later what this does. This is the actual Bluetooth stack then working. And then pretty much the last part is what happens when you have a new state. And when you have a new state, two things can happen, essentially. You either, the business logic decided that you should discard some devices, or that other devices should be opened. And this is what we're tracking here. So we say, well, OK, anything that is not in the state should go. Everything else should be kept. And then we iterate, remove stuff, release anything that we don't need anymore, essentially. And blah, 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 et cetera. And then we start checking the open devices. And all of those that are not to be kept, then we release them as well. And then for all the devices that actually have not been opened yet, we do the opening. So we open it as a, like method, and I'll show you later the implementation, the like Bluetooth stuff. But then the really interesting part is that we set a callback to say, whenever this device is sending data back, I want to do something with it. And this is where the bit craziness starts. To be fair, I did this just because then it would easily fit in one screen. There's ways to abstract this so that it's not that painful, of course. But yeah, like you can make it so that you can use the serialization if you want, not out of the box, but there's ways to do it. I even wrote a small preprocessor that you define some sort of models as data classes, and then it generates all this for you, but whatever. Again, there's many ways to abstract this. But the point is that if you actually look, Bluetooth hid information. So going back to the documentation, there is, where are you? Here. So when you receive this input format, this is the ID of the input format, you have this bytes payload happening. In particular, we are interested in the button status, which are 2 bytes, 1 and 2. And then inside of that, for each byte, every bit corresponds to a button, right? And that's what we're trying to get. And so we take the 2 bytes, and then one by one, we do these super ugly bit shift operations just to get out if the thing is actually clicked or not. Once we have it, we send, and that's it. Okay? And this is, again, like, this is the low-level work that the business logic doesn't really want to do. This is literally serialization, deserialization, not deciding anything, really. Yes. And that's it. Finally, once we have all of this, so we created this other thread with the devices manager, etc. At the end of all of this, what we do is we actually set those references at the beginning, the sort of promise that said, please give me a reference so I can send you back the state. We do set it here. And then this is, like, up until now, nothing has happened yet. This is all set up. And that's the beauty of actually making things immutable. You declare an initialization thing, and then everything else just flows after that. And so what happens is, this is the real now start of what you're doing. You start searching for devices. You search for devices, and once you find one, you get the name, you send it as a, where are you? As a method here. And you already set a callback that when the device will be removed, if ever, you remove it and you send it as an event. That's it. that's the end of our setup. Notice the plus because I'm chaining the closables, because why not? And then it works. The only thing you have not seen, and I can show you if you want, but it's pretty boring. This is the low-level, I don't know, search for devices, where you literally create this, call this IO hid, blah, blah, blah. You pass all the things, you do all the boilerplate, etc., which again can be abstracted, but here you see. And then you have this symmetrical disposing thing. And you only have to do this for the core foundation, right? There's not really any point in doing this sort of cleanup unless you're managing memory directly, which hopefully doesn't happen often. And once we have all of this, it's done. And now I want to try to show you if it works. This was the preprocessor running. This I was playing with language features, because why not? And let's see, what could possibly go wrong? Linking. And while it's doing that, now I, of course, made changes until the very last minute, so there's a very good chance that this will not work. But behold. So the trick is that you press the sync button, wait until the LEDs start going around. We can see, by the way, in the command line that this is running, and it's now open and listening for devices. Then you go to the Bluetooth preferences. Can I go on the other side? I want to go on the other side. No. It doesn't let me. Okay, let's do it differently. Again. Okay, not connected. We try to connect. Go back on the other side. Oh, yes, connect. Wait, generally when it does that, oh, whoa. That's not expected. Null pointer exception. Wow, that's something. Kotlin is null safe, remember. Where? Because the thing, no, actually, okay, I know why. This is, it's my fault. Don't worry. Let's start it again. I think every time I reconnect it that way, it does a weird, 1+, no. It does a weird, like, how can I explain this? Sort of like a mid-state where one part of it was there, but the other was not. And so it's not the way you expected things to be in that instance, because you need to try again, essentially. Oh, but, okay, there you go. So it actually did all the things. Yeah, okay, so we're here. Stuff happened, and of course. And then you can crash it remotely by pressing a button. Amazing, amazing, ladies and gentlemen. Again? No. Okay, so obviously I broke it just because. Why is that null? Oh, because I'm not passing any context. I totally broke it. How much time do we have left? Is it like none? Do you want to do it live? Because, no? If you want, like, yeah? Yes or nay? Yeah? Okay. So, what we want from this is to get back an input report, lambda, because this is a tape alias. Actually, go away. This is a tape alias for the lambda, right? So what we are not doing is actually passing the lambda back. And we totally need to do that. So, yeah, we're here. So we even create the reference, even dispose it, just never pass it to that. And so let's say call back ref to a pointer. And even just that might be it, maybe. Let's see. Where did I put it? Do you have any questions in the meantime? You look at you have a question. No? It's just your face. how long did it take me to build this? You mean the first hacky version? Like, well, once I figure out the other things, like, oh, you need to initialize the app this way, or you need to do the other thing the other way, I want to say 3 or 4 hours, maybe, something like that. It's not polished, obviously, like it's very, thrown out there. But even then, oh, come on. Let's see. Still? No, wait, it can't be. Did it even compile? No, I don't believe this. Say again? Yeah, but it really shouldn't be null. Like, the whole point is that we are creating a reference to it so that we get it back. But then at this point, let's debug it. Because why not? That's also one super neat thing that you can do, and it kind of just worked. Did I put the line or Kotlin? Well, I hope it's a line. OK, so this is the beginning. I probably have to then press. All right. Oh, wait, did it already crash? No. But then, wait a second. I think. So where did we put the breakpoint? Here. Let's actually. Are you really? Maybe that's a problem. Might be. Actually, let's do it like this. Let's say this before, and then we can just do this. And then I'm hoping, finally, OK. Trick, you should use the line breakpoint, because that's a native one. Super confusing. It's already being fixed. Don't worry. You'll have one breakpoint, essentially, or at least a very well-named breakpoint. And so again, and by the way, you can access pretty much anything on the Joy-Cons. You can access the gyroscopes and motion sensors, essentially. You can access the infrared camera. You can access the vibration, and you can make it vibrate in ways that are crazy. It's like a subwoofer, pretty much. Time is over. Well, you'll never know if it works now. There you go. But we are working on compilation speed. So next time it's going to work. Yes, come on. Yes. Yes, that's fine. Where are you, context? So it is there. Then what is your problem, context? Yeah, but I think that's supposed to be working. Well, we'll never know now. Guess it's something inside the Lambda. Next time, we'll have a full debug session just for that. Thank you very much. And remember to vote.